All right, so graphing angles, standard position. What does that mean? If I take this and start it here along the positive x-axis, Brianna, and then rotate it through some angle of 150 degrees, then we say this terminal arm is in standard position. Okay? It's almost a little redundant. This is where we start. By the way, Jakey, who came from Alberta, I just noticed when I marked his test yesterday, he didn't write for his angles. He didn't go like 30 degrees north of east. He just took it as standard position, 30 degrees. If he had one over here, he went 220 degrees. Now, I know what that means, and I wouldn't mark it wrong, but just because he was there and I said, well, let's just follow convention of how I taught it in this course. And okay. And you know, he knows both ways, right? But there's lots of ways you can write an angle. Of course, that's just one way. I could also write this another way. So there's three ways I could do that one vector there. Okay, but that's just how he did it in over there in Kettleton. So it starts here. The positive x-axis, that's the initial arm. It rotates over to there. This is what we call the terminal arm in bad penmanship, standard position. Okay? Wherever it is, it's in standard position because we started here and we're always going to start there. So like I said, it's kind of redundant. All right, but I could also go, we always go counterclockwise. Okay, that's the direction we go. I guess I better explain that. I could go the opposite direction. If I said plot negative 30 degrees, well then you don't go counterclockwise, you go clockwise. And that's there, okay? Now there is an equivalent angle that can go around that way. That's the same as 330, right? Okay, now we're going to get questions. Name two other angles that are coterminal to that one. It means they have the same terminal arm. They're in the same position. It's just you get to there by doing something different. And you know you can go around another 360 degrees and be in the same spot. And do it again, and do it again. There's infinitely many ways I could call this thing, right? So we're not going to ask you to do it infinitely, just a couple. Okay, lastly, the reference angle. Does that ring a bell? That's the closest to the x-axis. It's always acute. So if it's 30 degrees, well, the closest to the x-axis, if I go negative 30, is 30 degrees. But this guy, if that's 150, the closest to the x-axis would be over here. And you guys know that's 180, right? Let's write it. That's 90, 180, 270, and then back to 360. But remember, I started at 0. So if it's in quadrant 2, you might want to memorize while I subtract it from 180. That'll always work. Or just do the picture and see what it is. What would be the reference angle here? 30 degrees, right? Okay? And I don't think we're going to give you any weird ones like we did in grade 11 and just put one right there on the y-axis and say, what's the reference angle? Okay? Well, it's 90 degrees this way and it's 90 degrees that way. What quadrant is it in? Okay, who cares, right? It's not really. It's in between 1 and 2. I hope we don't get questions like that. Okay, draw the following angles in standard position. Does this ring a bell from Math 11, you Math 12ers? Recall doing this? I recall a lot of you saying, can we have like a lot of trig on the midterm? Because that was like easy. I like that stuff. I recall you hearing that from some of you, right? Okay. So, I like to draw a picture. Picture's worth 1,000 words. 70 degrees, that's there. Okay, give me something that's coterminal to 70 degrees. Add 360 to it. 70 degrees plus 360. If I go all the way around from there, what's that? Right? If I go 430 degrees, I'll get right exactly to that same terminal arm. What else is coterminal? Well, let's go the other direction. Because if I'm here and I go the opposite way 360, I'm going to be right back on top of it again. So if I go 290 from the positive x-axis, yeah, negative, thanks. In the other direction, I'll be right on top of it, right? So that's usually what we do. Like, there's infinitely many answers here. But this would be a question on a test. It would be multiple choice, and it would say 4 answers. Which one is coterminal? And then you can't just check someone who's going to go, oh, let's times 360 times 1,000, and then makes, you know what I mean? Okay. What's the reference angle here? Closest to the x-axis? 70 degrees. It's easy if it's in quadrant 1, because it's just the same angle. So let's give you something that's not in quadrant 1. 100 degrees. And we should know pretty accurately where to graph this. You know that's 90, so it's 10 degrees past there, right? What's coterminal with that? 100 plus and minus 360 degrees. So 460 and negative 260 degrees. What's the reference angle? Closest to the x-axis? Let's do that. Is that better, Brianna? You look really cute when you squint, but I'll be nice. Well, that's 100. This is 180. So from there to there, it's 80 degrees. Okay? I got to use a smaller pen. 560 degrees. Well, I go all the way around. That's 360. Yeah, and then I got to go another 200, right? Which is over there. And then you look here and go, okay, that's like 200. Ignore the 360. This is 180. So let's just do the reference angle right off the bat. What would that have to be? 200 minus 180 is 20 degrees. Okay? What's coterminal with 560? Let's plus and minus 360 degrees. That's 920, and that's positive 200 degrees, right? Same thing. Alrighty? So that's review. That's when Math 11 stops. Here's where Math 12 starts. Let's graph that guy. Oh, doesn't that make me think? That's 0 radians. How many radians is it for a whole circumference of a circle if r is 1? 2 pi. What did you use to convert 2 days ago? You used this thing, didn't you? Because these are equivalent, right? It's like converting centimeters to meters. These are equivalent. That's your conversion factor. This is the same rotation. Half of 2 pi is pi. So 90 degrees is half the way to pi, which is pi over 2. And then a pi plus a pi over 2, what's a pi and a half a pi? 3 over 2 pi, 1.5 pi, right? So where's 3/4 of a pi? That's a whole pi. I want 3/4 of a pi. There's a half a pi. So that's right there. But do we care? We don't want to convert this to degrees. That was like yesterday's stuff. What's coterminal with that? Well, we do the same thing. I want a plus or minus a full circle because it's going to land right on top of that terminal arm. But a full circle here is 2 pi. Now, believe it or not, this is typically the hardest part of Math 12. It's the grade 7 fractions. People get the trig, no problem. But you give them fractions to add and okay? So let's do it over here. What is 3/4 plus 2? How do you add and subtract fractions, boys and girls? I need a lowest common denominator, which is what here? 4. So I want to make that something, and that's like a 1 there now. It's 2 over 1. I want to make it a 4. How many times does 1 go into 4? 4 times. What's 4 times 2? 2 is the same as 8/4, isn't it? 4 goes into 8 2. Hey, yeah, it works, okay? So what is 8/4 and 3/4? 11/4 pi. Okay? So that's adding it. Now I want to subtract 8/4. What's 3 take away 8? Negative 5/4 pi. Okay? What's the reference angle? How far is it? Before we went 180 minus this thing, and that was pretty easy because it was all like numbers, right? Now we got fractions. What's pi minus 3/4 pi? What is 1 minus 3/4? Pi over 4. Alrighty. Minus 2/3 pi. I start here in the positive x-axis, 0. That's pi over 2. Pi, that is 1.5 pi. And then I can get back here and get 2 pi again. What direction do I want to go here, Reese? How do I call that? Clockwise. Clockwise. Minus 2/3 of a pi. Is that bigger or less than 1.5 pi? But I'm going the other way, aren't I? So I can't really think about it like this, can I? That's a whole pi. It is if I go this way or I go that way, right? Okay, so that's 2/3 of a pi. Is that less than a pi? If I divide this pi into thirds, then I'm going to get 2 of them, right? So that is minus 2/3 pi, right there. Right? 3/3 is a whole pi. I want 2/3. 1/3, 2/3, that's 3/3 whole pi. I want 2/3. And I went negative. All right. What's coterminal with that? Plus or minus 2 pi. Do you want me to write this out again? Or are we okay? I better. 2/3, I'm going to add, what's 2 in terms of thirds? 6/3, right? So I'm going to add that, which is 4/3 pi. And then I'm going to subtract that, which is minus 8/3 pi. Okay. What's the reference angle? How far is it from 2/3 to 3/3? 1/3 pi, or pi over 3, which happens to be 60 degrees. Does that make sense? It's 180 from here to here, right? That's 1/3 of 180, right? That's 45 degrees. Oh, you'll know that even better than me in a few days. Okay. 9/4 pi. 0 or 2 pi. That's pi. That's pi over 2. That's 3 over 2 pi. First of all, which way do I want to go? Positive. I want to go counterclockwise. How far do I want to go? What is this? I'm going to do it because I bet you some people would do this. Okay? Because everybody sucks at fractions. Hey, it's over 2 pi. What does that mean? It means I went all the way around to there, and then I got a little bit. So what is 2 pi in terms of 4? Yeah, so you want to go, that's all the way around once. That's 2 pi. What do you got left over? Pi over 4 I want to go, which is half of pi over 2, right? So I already did my reference angle. That's it. This is 9/4 pi, okay? So 9/4 pi minus 2 pi all the way around. How do I do that in terms of you guys looking at it? Okay, and then I got to add, what's 9/4 pi minus 2 pi, which is 8/4 pi. I got to go another 1/4 pi, which you can't read. Okay? All right, so like this is like 3 questions in one, isn't it? 1 mark, draw the picture. 1 mark, what's coterminal with it? 1 mark, what's the reference angle? Okay? So you don't have, you can get this easily without even drawing the picture, right? Okay. So what's coterminal? What's 9/4 pi? Let's just add plus or minus 2 pi. There's infinitely many choices, but let's just be, what's the word? Nice. Okay. 8/4, sorry, got dyslexic. 9/4, I want to add 8/4. That's 17/4 pi, and then 9/4, if I go the other direction, minus 8/4, yeah, 1/4 pi, which I kind of already did. That's my reference angle. Okay? Is there any more? Oh, I guess that's it. Now tomorrow is a really, really dinky little lesson. I'm not sure what I'm going to do, but maybe, no, I won't do it tomorrow.